Hey there, I'm Anne Plisse with Azul's product marketing team. And today we're talking about cloud cost optimization specifically for Java workloads. With me is William Fellows. He's the research director of S&P Global Market Intelligence. And Simon Ritter, our deputy CTO here at Azul. Now, our conversation is going to focus on two things. Number one, William's going to take you through some market trends and some data points that will be really interesting to what's happening that's leading to bloated cloud costs. He's also going to lean into some research based on conversations that he's had with your colleagues and your peers and what they're doing to address bloated cloud bills and specific strategies and how to reduce cloud bills. And then also we'll have conversations around how to make cloud budgeting and forecasting more predictable. And the second thing we're going to focus on is how your choice of a Java runtime can help control cloud costs. Here at Azul, we provide our own Java distributions to the market based on open source. We have a performance runtime that delivers performance gains for global companies and also helps them reduce cloud waste, which is a key part of our conversation. And most importantly, Azul is emerging as the primary alternative to Oracle for support of global Java estates. So Simon's going to go ahead and unpack that for you. So with that said, I'm going to go ahead and turn it back over to William. And William, I'll go ahead and have you dive into our presentation content.
Great, thanks for that kind introduction, Anne. So, hi everyone, thanks for joining today's webinar. I'm a research director at S&P Global Intelligence 451 Research, and I'm pleased to introduce today Simon Ritter, who is Deputy CTO of Azul. And as I'm sure many of you will know, Azul's been in the market since 2002, originally providing hardware for acceleration for Java workloads, and now leveraging its Java expertise to really optimize the efficiency and the performance of applications running on its JVMs with its fast runtime compiler technology. So, Simon, would you kindly introduce yourself and Azul to our audience?
Yes, thank you very much, William. So, as you said, my name is Simon Ritter, and I am the Deputy CTO at Azul. I have a lot of history in terms of Java because I joined Sun Microsystems back in 1996, literally about the same week that JDK 1.0 was released. And I followed Java all the way through the Sun years. When Sun got acquired by Oracle, I then moved to Oracle as part of that acquisition. I spent 5 years at Oracle. And throughout that time, I was promoting Java as a platform, helping to drive adoption of it, helping to get developers to understand how to use Java. And then at that point, I decided I would move and I would join Azul, and I've been there for the last 8 years, again, helping our users to understand all of the different ways that they can take advantage of the different versions of Java that we provide. As you said, we are a company that is focused purely on the Java runtime. We do that in a number of different ways, primarily through providing our high-performance runtime that we're going to be talking about during this presentation, called Platform Prime. We also have a straightforward build of OpenJDK called Platform Core, which is designed to deliver a supported version of Java, which doesn't have any differences from the standard open source. So that's what we're all about, is Java.
Great, thanks, Simon. Next slide, please. So I've prepared a few data points to tee up today's discussion, and I know that Anne will make these available to our audience, so you don't have to screen grab everything. So perhaps first, why don't we set the scene on where we are, with this adoption? And I think despite higher inflation and energy prices and overall belt tightening among enterprises, spending on public cloud continues to expand. I mean, really driven by new business and IT initiatives, especially application modernization and cloud migration. Even if overall growth is slowing, the market as a whole is still rising, as you can see from the data here. This is from our latest public cloud infrastructure market sizing report from the 451 Research Cloud and Managed Services Transformation Unit and Market Monitor Service on the supply side. This shows that the public cloud infrastructure market grew by about 25% from 2021 to 2022. It covers 315 supply side market participants right across storage, compute, and networking. And we estimate that sales will have an annualized run rate of about 13% over the next 5 years, from about 100 billion in 2022 to 185 billion in 2027. So cloud infrastructure vendors, well, they're adjusting to slowing conditions while optimizing the consumption of IT infrastructure and services to drive new business, and adding more and more services on top. And as organizations are sort of weathering these macroeconomic headwinds, the cloud vendors are shoring up customer loyalty with messaging around operational efficiencies and service optimization to really address concerns about runaway cloud spending, and to maintain and expand their customers' long-term IT commitments. I think we can say that customers generally feel that they are getting their money's worth, but the cloud budget overruns have increased the focus on cost management and optimization, which is now pretty commonly referred to as FinOps. And indeed, enterprises routinely point to their cloud expense in their financial reporting. I remember in his 2022 letter to shareholders, Andy Jassy, the Amazon CEO, of course, who was the AWS CEO until 2021, referred to customers optimizing their AWS spend to weather some of these pressures was one of the headwinds that the company is facing, overall. And even now, cloud cost optimization continues to impact revenue growth across the hyperscaler segment. If you'd like to move on a slide, please. So on the demand side, what this data is showing is that there's an ongoing mismatch between public cloud budgeting and what the actual spending is. So this is data from 451's Voice of the Enterprise 2023 Cloud Spending Survey. And this comes from a panel of enterprise practitioners, a global panel, which we have built, own and operate, and who we survey on their spending intent across the sectors we cover. So the data here, the light green in 2021 and the darker in 2022, suggests that organizations had a bit more trouble keeping cloud spending in line with their budget projections compared to 2021. And indeed, more than half, so I guess 56% actually of respondents report that spending on public cloud was significantly over budget, by 30% or more, or somewhat over by 10% to 30% in 2022, which was up from 45% of respondents in 2021. And I think something to note here is that in the kind of discussions around this, that the egress charges were highlighted by many, and is an increasing issue for suppliers looking to take advantage of public cloud and on-premise resources, used together, which we call, cloud to ground and ground to cloud. Next slide, please. So the same survey looked at the biggest reasons for this overspending, and there are clearly, a lot of factors which cause the overshoot. The need to scale up resources to address unexpected demand emerges as the chief culprit here for the overruns, and I guess it's cited by 27% of respondents, which actually was up from 22% in 2021. And other factors include the overcommitting to purchase of resources, the lack of governance and usage guardrails and so on, and a lack of pricing transparency as well. Now, the sudden need to scale clearly is not a bad problem to have if the underlying issue is the unanticipated success of a new business or IT initiative that results in additional sales or improved customer experience and so on. But on the other hand, spending more on cloud to satisfy growing demand doesn't necessarily mean organizations are increasing revenue at the same pace. And determining whether and which cloud investments are bearing fruit is really the chief goal of what we now refer to as this FinOps discipline. Are you getting the cloud bang for the cloud buck, as it were? And FinOps is having a real moment at the moment. Other primary causes of the overruns, I think, relate to organizational issues, basic cloud hygiene, or lack of there, and the ins and outs of hyperscaler pricing. I think with regard to the latter, the hyperscalers responded to customer demands really with a range of new pricing models and other contract incentives and instruments designed to help customers derive more value from their cloud spending. Simon, perhaps I can bring you in here and perhaps to share some of the experience from the front line. I wonder to what extent any of this is driven by Java workloads, and in your experience, how much wastage or overage is too much or too little. Perhaps you could talk about some of the the Java issues in terms of these macro issues here.
Absolutely. I mean, as you say, if we look at the sort of marketplace as it is, Java is really the kind of number one platform that people use to deploy enterprise server-side applications. The reason for that is what's been true right from the very beginning is just the scalability that you get to scale internet-sized workloads without having to re-architect things in a radically different way. And so we're seeing that, as I said, most enterprises are using Java somewhere in terms of their mission-critical back-end applications. What we're seeing, though, is, as you quite rightly point out, the second point here around over-provisioning and committing more of the resources than are actually needed. And the question we've got to ask there is, well, why are we over-provisioning? And the reality of that is that if we look at the architecture that most people are using in terms of deploying to the cloud, we're dealing with microservice architectures. Break up a monolithic application into multiple small services. And that has a number of advantages, one of which is the ability to be much more dynamic in terms of how we can provision those services. Rather than having a monolithic application where we have to throw more resources at the whole application in order to address changes in workload, what we can do is we can focus on individual services and say, well, when they become a bottleneck in terms of the architecture, all we do is we spin up more instances of that service to address the increase in workload. And then when the number of transactions drops down, we can then shut down those services and be very dynamic about it. That's a real advantage of the cloud over more traditional architectures. But the problem we're seeing is that with Java workloads, because you have a JVM that gives you that scalability, it gives you that performance, you also have a warm-up time associated with the services. It needs to go through this stages where it identifies which code is being used most frequently, compiling that into things called bytecodes. What is that in order to be able to react very quickly to changes in workload, which many people have to do, people are saying, well, we can't spin up a new instance quickly enough and have it respond in the time that we need. So what we'll do is we'll spin up instances and keep them in reserve. So we'll have them running in the background. And then when we need those services, we can just bring them in, have them direct the transactions to those services, and they're ready to go. But that's very inefficient because we're keeping those services running. And because it's a utility-based pricing model, we're keeping those services and having to pay for the instances that we're running in the cloud, keeping those things going. So what we've been doing at Azul is looking at how can we make that work in a more efficient way. How can we take Java, maintain this idea of that scalability, of that performance that we have, all those good things, but address some of the issues, especially in that microservice cloud architecture. And so we have things like Ready Now, which is where we can have a running service and then we take a profile of it so that when we need to start it up again, rather than have to go through the whole learning process of finding the code that's being used very frequently, we already know. And so we can compile that very quickly and address that warm up in a much quicker way. Another thing that we've done is to take advantage of the way that the cloud works and the whole sort of distributed computing environment so that we can say, well, let's take that compilation part of the application out of the JVM and make it into a centralized service, so a compilation as a service. And that way we can offload the work from the individual microservices. That reduces the size of the instances that we may have to provision for each service because it's not having to do its own compilation. And then we can also have a memory associated with our centralized service so that when we have the same service start up each time, we don't have to compile the code each time. We can cache it and then we can make it available as it's required. And that's a much more efficient way of doing things. So it addresses that big problem that people have in terms of over provisioning. So that's what we've been doing at Azul.
Great, thanks, Simon. And it really brought home to me actually the sort of critical role that Java continues to play in modernization and development. I attended the VMware Explore event in Barcelona recently, and Java is really front and center now of the VMware Tanzu portfolio for development and modernization. So yeah, it was really really interesting to see. Next slide, please. So when we asked this, the panel, the same panel where the previous data came from, what the primary factors behind the planned increase in cloud spending or public cloud spending in 2023, the top goal there is to support new projects, followed by improving application performance and reliability. I think reducing the cost of operating and supporting IT infrastructure is becoming more important as companies, they seek to, conserve capital. And I think that overall, though, it points to the fact that application modernization is speeding up, and there's a kind of a tailwind here from the hyperscalers, who have been, trying to educate organizations that they need to go faster with their modernization and transformation efforts in order to realize the maximum benefits of cloud, whether it's better, faster, or cheaper, or some combination of those. Next slide, please. So this slide looks at the planned spending that enterprises have on adjacent services. In other words, the value-added services which are attached to cloud and are now so important in terms of the new revenue generation and the opportunity for third parties and so on to take advantage of the embedded, the already deployed cloud infrastructure. So organizations, anticipate continued growth in spending on these services to support their deployments, particularly around security and compliance monitoring. And that was about 58%. You can see there on the bottom row in the dark green, and 54% on modernization, 51% on cloud integration services. I think IT cost optimization was one of the key areas for the reined in spending, but I think that's an effect of the accelerated sort of interest in FinOps activities, which have been put in place in 2022 in anticipation of the sort of continued macroeconomic uncertainty. Next slide, please. So now I'm going to change tack a little bit and to look a bit more forensically at the infrastructure and resources and so on. So since 2016, 451's Cloud Price Index, we've tracked the shifting cost of a standard basket of cloud goods and services, collecting pricing and following benchmarks to reveal what the market is paying for compute storage, bandwidth, databases, load balancing, and so on, and a host of other cloud-based offerings around the world. A bit like the Consumer Price Index tracks a basket of consumer goods and services, the Cloud Price Index tracks a basket of cloud goods and services. And with a few exceptions, benchmark pricing has held steady now since the 2020s, when there was, well, between an 8 and 15% drop in prices that followed the rollout of CPUs with better price performance. And since then, the benchmark has been pretty steady. Now, many factors go into benchmark changes. The most significant driver for compute reductions in price reductions in recent years has been the substitution of newer generation processors. So new VMs based on AMD's EPYC processors, for example. And in non-compute services, US benchmark prices for object storage, archive storage, data transfer, and in-memory caching ticked up from the year before, while database, serverless, and container benchmarks were down. And these were primarily due to wider rollout of cheaper services based on AWS's custom-built AMD Graviton processors. So we can see that Graviton is now having, a meaningful impact on the market, and offering customers, another choice, another route here. And from our point of view, Graviton is delivering, impressive results. There was obviously the three-way engineering proof of concept, which combined AWS Graviton 2s with software from NEC, hosted by Japan's mobile giant NTT, which delivered a pretty significant, average reduction in power consumption, using Graviton 2 versus Intel's second generation Xeon. So, there are certainly places where, it really is having a meaningful impact now. So, Simon, perhaps you could share some thoughts here on price benchmarks for Java workloads, and, what are the ideal targets for cloud cost optimization, and the role that you think that Graviton can play here.
Yes. And as you say, I mean, Graviton is kind of a little bit of a game changer, because what's going on there is that we're using a different architecture. Rather than using the Intel x86 instruction set, which even the EPYC-based architectures are using, Graviton is ARM-based, so it's a very different one. And typically, if you're using, C or C++ based applications, you're going to have to recompile everything to take advantage of that new architecture. One of the great things about Java is that because it is platform neutral, you can take the same application without having to change any code, without even having to recompile your code, and you can run it on your Intel architecture, or you can run it on Graviton without any problem. And that's one of the important things that we've been doing at Azul, is we made sure that we were able to deliver platform prime as quickly as possible. Reductions in terms of the Graviton are through performance from the JVM itself. And I mean, if you look at the numbers that AWS quote from the Graviton side of things, they are saying that they get a 40% price performance improvement over Intel's 5th generation, and more importantly, a 72% drop in power consumption. And if you think about the way that we're all aware of, the carbon footprint of things at the moment, that's a very significant saving to be able to make. And if you look at the Graviton 3, then they will say that they get even 25% more price performance over Graviton 2. And what we've seen is that in terms of the performance numbers, you say about different things, different workloads, there are a lot of kind of frameworks that people use that they may not even realize that these things run on Java. So if you look at things like Kafka, if you look at things like Cassandra, Spark, Elasticsearch, Hadoop, all of those run on Java, on a JVM. And we can see that in terms of the throughput that we can get with Platform Prime, we can get significant higher throughput. Just to give you a couple of examples, Cassandra, we can get 23% higher throughput over a standard OpenJDK virtual machine. With Kafka, it's over 40%. And that's, remember, without changing any code, without recompilation, you're just changing the JVM underneath. And if you then combine that with the use of the Graviton processors, we can look at benchmarks we've done of comparing using standard benchmarks on Graviton and with Prime versus OpenJDK, and we're getting 26% faster on Graviton 3 versus OpenJDK, and 18% faster on Graviton 2. So there's a lot of improvements in performance and throughput that we can get, which is going to bring that price down even further. And it's important to understand that in terms of our support of Graviton, we're a Graviton ready partner with AWS. So it's ready to go. You can deploy it straight away. There's no issue with using that.
Oh, that's impressive. Next slide, please. So in addition to publishing quarterly cloud price benchmarks, if you like, the index tracks the SKU changes. In other words, the services that are added, removed, price increases and decreases across the those three hyperscalers. And in 2022, we logged more than 1.3 million adjustments. The vast majority, as you can see here, were from AWS, whose sort of roster of infrastructure and software services is really well organized in terms of the discipline of the how it's segmented, the granularity in pricing and APIs and so on. Anyway, the broad picture is continuing momentum across the providers' portfolios, and in fact that's accelerating. I just got the data from October 2023 when we found 250,000 changes in just 1 month. So the three companies introduced a breathtaking variety of virtual machines in 2022. Compute SKUs accounted for nearly 90% of service additions. AWS launched more than 30 new instances, Azure was 47, and so on. And it's no accident that many other products are aimed at powering compute intensive, high performance, accelerated and sort of special purpose processing, as the providers are all creating these capabilities to meet the needs of different customers, different modern workload requirements. So that's only accelerating. There are non-compute service additions as well to reflect modernization around, especially around database migration, hybrid networking, and so on. Simon, I mean, this is a vast number of choices for how does customers keep up with the volume, the velocity, and the skills they need to determine what's right for Java, let alone the impact of what different architectures might be that they don't necessarily have at the moment or yet.
You're absolutely right. I mean, as you said, 250,000 new SKUs in a month. It's very, very difficult to be able to keep up with all of those things. And I think what we sort of see in terms of the market is that people are trying to focus on, the different parts of the stack. And that's where looking at the runtime for your Java platform is very important, because if you focus on that initially and you say, right, let's get that to the highest level of performance that we can, also one that can address these specialized instances that are becoming more and more common, as you said, across the different cloud providers. And that's where Platform Prime really kind of can help deliver what users need. So you've got that high performance JVM. That gives you that level of baseline performance that's as high as possible. But then when you start thinking about these specialized instances, compute intensive tasks, something that's becoming very, very common, especially around the fields of AI, machine learning, and so on. And what we've done with Platform Prime is to focus on how can we deliver that in terms of optimizations, so that if you are doing compute intensive tasks, our JIT compiler that generates the code for the particular platform you're running on, whether it's Graviton, whether it's Intel or so on, that will enable better use of the microarchitecture instructions that are available. So things like vector processing is a very common technique that's used at the processor level to deliver higher numerical intensive application processing. Where we can use that the underlying code. That, as I say, enables the user service from AWS or CGP, and we know that the underlying JVM is going to be able to support that because we're using Platform Prime, so we can take advantage of that and get the best possible level of performance, which reduces the costs associated with it.
Yeah, that makes sense. Great. So next slide, please. So this data sort of brings us back to where applications are actually, running. And I think what this data shows really is that, hybrid approaches that accommodate the sort of range of different workload requirements are really sort of gaining momentum here across all these different application types. I think it points to the fact that, application modernization is a multi-year, incremental and painstaking, process for enterprises, and they are, ramping up or increasing the pace of their work. And I think, given the pace of innovation amongst the cloud and software providers themselves, this is enabling organizations to move forwards with a bit more confidence, and less risk. Vendors like Azul are providing important on-ramps to organizations so they can take advantage of some of these newer technologies and resources, and so on. Next slide, please. So what is the organization's strategy for packaging environments? This has always been interesting in terms of whether containers are going to dominate, or whether there still be VMs around. I think what this says is that basically there's a 30-30-30 split between the use of cloud containers inside VMs, or just VMs, in terms of how organizations are packaging their both modernized and their net new workloads, which suggests there's, at the moment, there's plenty of runway ahead for each of these approaches. Next slide, please. So here we can kind of wrap things up a bit. When we asked our panel which vendors they would work with on their application modernization efforts, I think it's a little surprise that the vendors of the software themselves came out on top. But I think it's good news for ISVs, and it's good news, I think, for Azul specifically, because it's those vendors with complementary software offerings which are a strong second here in terms of who organizations would choose to use for their modernization. Perhaps, Simon, you could talk a little bit then about what you bring to the party here for organizations that might be looking or considering, third parties to help them with this.
Yeah, I mean, the thing about what we've been talking about is the Java runtime. It's what you need for every Java or Scala or Kotlin-based application that's compiled into bytecodes. And what we do is to provide an alternative to one that's based on OpenJDK, the open source version of Java. But the important thing to get across about that is that it is identical in the point of view of functionality. Your applications will do the same thing in terms of what you've asked them to do. And you've got an absolutely the same from the point of view of the standard as the other builds of Java. So we use the same basic starting point of OpenJDK. We make some changes to it, and then we test it using the same set of tests so that it is functionally equivalent. In terms of what we can deliver in terms of performance, we can do things like changing the way that the garbage collection works. That's always been something that's introduced latency into JVM-based applications, because the way that the application or the algorithms used to work was around having to pause an application to do the work of reclaiming memory in a safe way. It was going to move things around in memory. You don't want changes being made to it at the same time. So that would introduce considerable latency to certain applications. What we did was to find a way of doing that so it was fully concurrent and doesn't have to do any pauses to the application. So it's then running faster. The second thing we did is around this idea of just-in-time compilation. We have this compiler called Falcon. And as I've already said, in terms of things like vector operations, we can highlight that. We can identify many more places where we can use that. And that delivers that higher throughput that we see in terms of things like Kafka and Cassandra and so on, because we're compiling the code in a more heavily optimized way. I also mentioned Ready Now as a way of eliminating the warm-up problem. So if we're using microservices, I talked about cloud native compiler, all of those things that sort of bundled into this idea of an identical Java runtime from the point of view of functionality, but giving you different performance characteristics. So it's a very easy switch. You don't have to change your code. You don't have to recompile it, and it enables you to run your applications faster with lower latency. So I think that's what we really bring to the story here, is the ability to lower your cloud costs by doing more with less.
Great. Well, I think that's a neat way to tie it up. Thank you, Simon, and thank you to the audience here. I'll turn it back to Anne.
Thank you so much, Williams. And thank you so much for listening. And I really hope this conversation resonated with you and maybe some of the challenges you may be experiencing. So, William, thank you so much for your time and for the insight. Simon, thank you so much for your point of view. And who knew? A Java runtime can help control cloud costs. So if you're interested in learning more about Platform Prime in your own environment, go ahead and download Platform Prime. You see the URL and the coordinates there. If you do want a copy of this presentation and the data points to help with conversations in your organization around some of the subjects and data as a part of this webinar, please feel free to reach out directly to me. And I just want to say thank you so much for listening, and we appreciate your time today. Thank you.